question number 2. This is involving absolute value function where you have hx equal to 2x minus modulus x over modulus 3x minus 2x. So let's see here. For modulus x, let's open up the definition. This is equal to x if your x is positive. This is equal to negative x if your x is negative. So again, let's open up modulus 3x. So modulus 3x is 3x if your 3x is positive. And this is equal to negative 3x if 3x is negative. So let's rearrange this domain here. So this function here is equal to 3x if x is positive. And this is equal to negative 3x if your x is negative. So this question asks us to find out what is the limit of hx as x approaching 0. So let's check 0 from the left and also limit of 0 from the right. So let's see here, limit of hx as x approaching 0 from the left. So this function hx here, we need to choose the absolute value for the value x is a negative. So we need to open up the modulus value here, but we need to pick where x is less than 0. So for modulus x, we need to substitute with negative x. And for modulus 3x, we need to substitute the value of negative 3x because this is the value if x is less than 0. So let us simplify here. 2x plus x is 3x. And for this one, this will result in negative 5x. So let's cancel out the value of x. And you are left with limit of negative 3 over 5 as x approaching 0 from the left. So limit of a constant is just a constant. Next, let's do for limits of hx as x approaching 0 from the right. So again, for absolute value, we need to take the value for x is positive. So for modulus x, we need to take the value of x, substitute this here. And for modulus 3x, we need to take the value of 3x because this is the value if your x is positive. So let's fill in 3x here. So now let's simplify. This is x and this is equal to x. So let's cancel out. So you're left with 1. So limit of a constant is again a constant. So now let's conclude our answer. Since limit of 0 from the left of hx is not the same of limit of x approaching 0 from the right, therefore limit of hx as x approaching 0 does not exist. Next, let's see this example here. Limit of modulus x minus 2 over x minus 2 as your x approaches 2. So let's do this. Let's open up your modulus. So modulus x minus 2 is equal to x minus 2 if x minus 2 is positive. And this is equal to negative x minus 2. Okay, put this in bracket. If this value here, x minus 2, is negative. So let's rearrange this. Put negative 2 on your right hand side. Therefore, this is equal to x minus 2 if x is more or equal to 2. And this is equal to negative x minus 2 if your x is less than 2. So let's refer to this function here whenever we want to solve later on. So since you want to find out what is the value of limit of this function as x approaches 2, you need to check from both sides, 2 from the left and also 2 from the right. So let's start with x approaches 2 from the left. Therefore, let's open up the modulus here. So 2 from the left is this value here. So let us substitute this in your numerator. So let's put this over x minus 2. You can see that this term is the same. Let's cancel out. So you are left with negative 1. So limit of a constant negative 1. This is again negative 1. Next, let's see limit of 2 from the right. This is your function. So let's substitute the absolute value here for the value 2 from the right. So for 2 from the right, let's take the value of x minus 2. So let's fill in your numerator over x minus 2. So since this is the same term, let's cancel out. So you're left with 1. So limit of a constant is again a constant. Therefore, let's conclude our answer. Since limit of 2 from the left is equal to negative 1 and limit of 2 from the right is 1, this is not the same. Therefore, we can conclude that limit of x approaching 2 for this function here does not exist.